Alright guys, what's up? I wanted to make a brief recording. I only have half an hour until class comes in, so hopefully it's a brief recording over the Chapter 2 Mastery on Proportional Relationships. You do have a separate Progressing to Mastery. It is over here in the Progressing to Mastery folder, so get one of those if you need one. I believe I had those printed in yellow as well. They should be back tomorrow morning before you guys come to class. But let's dive in. So, when we look at a proportion, we know that a proportion is two fractions that are equivalent to each other. So when we're trying to select from this list, you can say, how do I go from 5 to 10? Well, I would double. Do I double going from 12 to 25? No. So that tells me that is not a true proportion. How do I go from 3 to 9? I triple. Do I do that going from 8 to 25? No. Tripling would make that 24. How do I go from, let's zoom this a little bit more. How do I go from 6 to 12? I double. How do I go from 9 to 18? I double. So since I can see that in both of these, this is a times 2. C would be your correct answer there. In number 2, the two numbers that have an equal ratio, we would have to take 21 over 24 and divide by the same thing on top and bottom that would allow us to get to an equivalent ratio. So I think through my values, and a lot of people that chose the wrong answer here made the same mistake. So we're trying to find a common factor that we can divide from both of these. A lot of people thought, I'll divide by 7, and they said this is 3, and that's 4. But 24 divided by 7 does not give you 4. So that was the incorrect answer. You did not want to divide by 7. What we actually see that we can divide by is 3. So when I divide by 3 on top and bottom, I get 7 over 8. So H would be your correct answer there. In number 3, we have a situation represented by y equals 14x. Guys, we use this equation a lot in the y equals mx form. This m is our multiplier. So that's why we use the value m, but it is technically called the constant of proportionality, which that comes back in a later question asking what this value is. But when we look for the constant of proportionality, here it is just 14. It is the value that multiplies by the x. So you could notate here that your constant of proportionality is just 14. Which proportion is equivalent to wx equal to yz? A lot of people got this wrong, and it's actually on my poster right up here with different letters. So it tells you after we cross multiply. So what you want to look at is when I cross multiply, this would make wz equal to xy. And that is not what we're looking for. We're looking for wx equal to yz. So look for where does w multiply by x. It doesn't happen there. Here w multiplies by y. Here we get wx equal to my other cross multiplication of yz. And that makes J your correct answer there. And number 5, a ratio that is not equivalent. Well, let's see, how do I go from 1/3 to any of these others? I have to be able to multiply the numerator and denominator by the same value. So if I look at 1/3 and I multiply the top and bottom by 2, I get 2 over 6. So that is equivalent. If I multiply the top and bottom by 4, I get 4 to 12. So that is equivalent. If I multiply the top and bottom by 3 to make my numerator 3, I'd get 3 over 9, which means 3/4 is not equivalent to it. And let's check our D option. If I multiply by 5 to make my numerator 5, my denominator does become 15, and 5/15 will work. 3/4 is the only one that does not work. We look at number 6. We need the most expensive per ounce. What we're talking about here is cost per ounce. So we're going to do dollars divided by numbers of ounces. The people that made mistakes on this, I think, did their division backwards. So what we want to do here to find that value is the money, the dollars, divided by the number of ounces. So that 239 divided by 24 would be 0.099, and that goes on 5/8. If I do the division in my second one, 329 divided by 32. This comes out to be 0.1028. If I do that division down here, $1.79 divided by 16, that becomes 0.11. And of course, all of these are in dollar form right now, because we can't say this many cents, because really there would be a dollar sign out here, since we did dollars per ounce. And to finish us off, do $1.89 divided by 20, and we get 0.0945. So when we look at the most expensive per ounce, that is going to be option H right here, which comes in at about 11 cents per ounce. We come up here to 7, the trap door that might have got a few of you guys, is that this is looking for least expensive, where question 6 was looking for most expensive. So be careful that we carefully read every problem. So again, we're going to do dollars divided by ounces. So here we do 259 divided by 13 ounces. That will give us 0.199. And we could go on if we wanted to. We do our 369 divided by 11.4. This gives us 0.3237 if we round that. 399 divided by 12 would give us 0.3325. And this is why I told you guys to get out a separate sheet of paper to write things on. There's a lot to keep track of here as we do this. 599 divided by 20, so that would be 0.2995. So when I look through these and I look for my least expensive, it's going to be option A, coming in at just about 20 cents per ounce, since this 9 would round up and make that 20 cents. So there, question 7 would be option A. Now, we have to set up a proportion for this problem, and we're given some information. We have a ratio of 2 to 3 that represents boys to girls. So if I see 2 to 3 like in F, I know that's boys, girls. Boys are on top, girls on bottom. So if N is the amount of boys we're looking for, this will work. If 12 is the amount of girls we have, this will work. So we see if there are 12 girls, well, there were 3 girls. Now there's 12 girls. 3 to 12. The bottom agrees it's girls and girls. So the top, this is boys and boys. So how do I go from 3 to 12? Well, that's a times 4. And what a lot of people missed here is how many boys are there? This question needs to be answered. What is the value of N? So if we multiply by 4 on top and bottom, that value for N turns into 8. And F is obviously your choice there. Why the other ones aren't your choice is here, 2 and 3 get separated, and they need to be in the same ratio. So right now, they took boys and put girls over here, and then they have girls down here, because we know how many girls there are, and this would be the new amount of boys. This doesn't make any sense. Here, we again separate, and they have boys, boys was the 2. So we have boys right here, girls right here. Now, this could work going like from one proportion to the other, from one fraction to the other side, only if they stay on top or stay on bottom. The fact that one's on top and one's on bottom and they're on separate sides of the proportion, this does not work. And over here, same thing. We have our girls over here and our boys right here. That original ratio we've been given, it is 2 separated. It either needs to be top and bottom on the same side, or both tops or both bottoms. This will not work. So F is our option. The number of boys would be 8. And number 9, we just have to solve this proportion. It's very similar to what we just looked at. How do I go from 4 to 12? I can multiply by 3. And when I multiply my numerator by 3, I get an answer of 9. Here, we're just solving the proportion again. Most of us got this, I believe. We see, how do I go from 2 to 20? That is a multiplication by 10. So on the bottom, we'll do the same thing, and we'll get a value of 30. Now, this asks us to set up and bold, underline, capitalize, solve for x. A lot of you did not solve for x. So let's set up our proportion. we have that 1 inch represents 15 miles. So again, the easiest way to set this up is keep that original ratio, together on the same side of the proportion. 1 to 15, 1 to 15. Both of these look good, A and B. Here 115, here 115. D is right out. Because my original proportion is on top, bottom, left, right, it is way too spread out. D, automatically gone. Here, 1 to 15, this could work if only this is inches and this is miles. So then my 75 would have to be inches, and it's not, it's miles. So now C is also out. I look at A. If this is my inches, because I know 1 inch equals 15 miles, then inches has to stay on top. Is 75 our inches? No, it's our miles. That's right out, leaving us only D left. When we look at D, we have inches over miles. X is my unknown number of inches.
Good afternoon, Juliet Baggiano. Please come to the office.
Over.
Juliet Baggiano to the office, please. Thank you.
Over my known amount of miles of 75. So this works. Now we have to solve for it. So I'm going to clear all this ink now that we know that B is our right choice. So I can ask myself, how do I go from 15 to 75? Some people struggle with that. That's actually a multiplication of 5. But if you struggle, don't worry. Cross multiplication will always work. So what we want to do is cross multiply. 1 times 75 is going to equal your other cross multiplication of 15 times x. That's going to give me 75 equal to 15x. And to get the x by itself, and these skills are useful on future problems also, we just divide both sides. Since my 15 and my x were connected through multiplication, we divide, and that solves out. That x is going to be 5, and if we give it a label, it's going to be 5 inches. For 12, same type of problem. We have how many dollars he makes for how many hours he works. It's $4 for 1 hour. I can actually stop right there. An hour. It doesn't say 1, but it's inferred. An hour is 1 hour. So here, if I look at this, this would be dollars over hours. Well, would this be dollars over hours is the question you want to ask yourself on each of these. $4 for 1 hour, unknown amount of dollars for 18 hours. That's exactly what I want. So actually my first option here, this is what works. So F is my answer choice. And a lot of you figured this out by just knowing, if I make a certain amount for 1 hour, I can just multiply by 18, which is what happens right here. We multiply by 18. So I just do 4 times 18. I know 4 times 10 is 40. 4 times 8 is 32. Sorry, not times, plus there. So we get in total, Sam would make, I guess we can leave the dollars there. He would make $72. This was just me breaking up that multiplication. So F is your choice. Sam would make $72. In 13, same type of problem, just kind of phrased a little differently. I like to draw pictures when we have problems like this. So we see that a tree's shadow is 135 feet long. We don't know how tall the tree is. So when I start to set this up, I'm going to scoop this up a little bit. I would just say there's a tree of some height, shadow of 135. And shadows can be shorter than the object or they can be longer than the object. So I don't know if this is drawn to scale. I'm just drawing a picture to get me started. What else I know is a yardstick is 9 feet. Its shadow is 9 feet long. So a yardstick I know is 3 feet tall and its shadow is 9 feet long. So if we wanted to set up a proportion for this, we could set up the height over the shadow. So we could just say height over shadow equal to my height over my shadow. Now another way always to solve a proportion is to check not only how do we go left to right or right to left, but we can also check how do I go from top to bottom or bottom to top. I can see that my denominator is triple my numerator, or my numerator is a third of my denominator. So to find this numerator, I know that it's going to be a third of my shadow of 135. So I calculate out 135 divided by 3. Now I know that approximately, before I do this, 135 is close to 120. 120 divided by 3 would give me about 40. When I look at these options, only one of them makes sense. But when I do this division, it is exactly 45. So this tree must be 45 feet tall. Now, the varies directly problem. Some people are getting goofed up on this, and I think you're just getting screwed up because of the vocabulary. When we have direct variation, that just means it's a proportion. So when x is 4, then y is 7, that goes together. That's like saying the ratio 4 to 7, or writing the ratio 4 over 7. That is going to vary directly, so it's going to do the same thing when my x value or my y value changes. So now that my x value becomes 20, well, ask yourself, where was my x? My x was on top, my y was on bottom, so my x should stay on top. I should put that new x on top. My y, I don't know what it is, but we can solve it. How do I go from 4 to 20? If I need to figure that out, I can say 20 divided by 4 is 5, so that's the multiplication there. 7 times 5 is going to give me a value of 35. Now we have a scale for a map. Same setup. Centimeters represent a certain number of meters. So when I set up 1 centimeter over, sorry, not meters, kilometers, 10 kilometers, that's going to equal so many kilometers based off 8 centimeters. Well, centimeters starts in top, so I got to keep it in top. And I don't know this value, but what I can ask myself, how do I go from my original scale to the amount that I've measured? Well, that's A times 8, and do the same in the denominator, and I get that this would be 80 kilometers. And I was still kind of nice with labels on this test, but realize that here very soon, if it doesn't have a label, it's going to get marked wrong. Another proportion here, this one's trickier to solve. I will give you that. The problem's starting to get a bit more difficult. So we have that Juan walked 8 miles in 30 minutes. We have miles compared to minutes. So I'm just going to set up 8 miles over 30 minutes. We are then asked how far would he walk in 49 minutes? So where would my minutes go? It would have to go on bottom here. And I don't know what my numerator is. Now the problem here is going from 30 to 49 is rather messy. You could do 49 divided by 30 to find out what that multiplication factor is. Or let's just make this m for miles. We can cross multiply to solve this problem. So I'm going to take 30 times m. That gives me 30m. Then I'm going to take 49 times 8 for my other cross multiplication that this will be equal to. So 49 times 8 is 392. Now that is not my answer because we're trying to solve for m. Remember, m is connected with the 30 by multiplication. We need to divide, so we're going to take that 392 and divide it by 30, and we get just slightly over 13. It's 13.06 repeating forever, but it says round to the nearest integer, so this would just be 13 miles. Josh can wash 3 cars in 60 minutes. Again, I can set this up as a ratio. I can say 3 cars over, you might as well write that out, 60 minutes. But here's the thing. The next value is given to me as 4 hours. Now some of you, I thought this was really creative. You converted this hours amount into minutes so that you could put it on bottom and agree. That's a great technique to use. Another technique I could use is say, if this is in hours, and if I want to plug hours into here, do I know how many hours this value is? Well, we do. 60 minutes is just 1 hour. So I can convert that unit and make this problem easier. How do I go from 1 hour to 4 hours? Well, I just quadruple or multiply by 4. We're going to do the same thing on top, and we find out in 4 hours, Josh could wash 12 cars. Tickets for a volleyball tournament cost $7 each. This goes back to what we did in class. When I would ask you, okay, how much will we make off 2 tickets? How much will we make off 3? How about 10? How about 20? And we'd work up to the point where we see 7 times the number of tickets sold is going to give me the money that we make. Well, which of these represent that if X is the number of people who buy tickets? It's going to be equation F right here. Then there's nothing else to solve. Now, when I said you may want to set up a proportion to start the solution process, we could say $7 per 1 ticket. How many dollars per X tickets? Then we would cross multiply, which gives me 7X equals however much we made. We find out that we made $17.50. So that gives me 7X equal to $17.50, which is exactly what we have in solution F right there. And 19, it's the same problem as the tree and the yardstick, except now I gave you a picture. So 6 and 8 do not compare with each other as nice as 3 and 9 did. So what we can do here instead is set up our proportion. We can take the height of the lamppost or whatever it was over its shadow equal to the other height of 6 over the other shadow. Realize here I've done both heights on top, shadows on bottom. My tops agree, my bottoms agree, both heights, both shadows. So going from 8 to 18, kind of difficult. None of this really seems to work out very nice. Let's cross multiply. 18 times 6, just to make sure I get this right, that is 108. 8 times h just gives me 8h. And then how do we get this h by itself? We're going to want to divide by that 8 to get rid of it. And this gives me that h is equal. Oh, so our first off, either of these work. B or D both work here, because notice height over shadow, height over shadow, shadow over height, shadow over height. The only difference between B and D is flipped compared to B, or vice versa. But when I take my 108 and I divide by 8, I find out that the height of the lamppost is 13.5, and that would have the same label as everything else of feet. On to the back page. Now this one threw a few people for a loop. It says the graph represents the packages of pencils sold and the packages of erasers sold. And we ask you for how many items were sold per hour. So forget about sold. This is really items per hour, which is quantity per tells me to divide by hours. So what I want to do is take this point and look, how many hours was it? How many items was it? So for pencil packages, it was 35 items in the span of 2 hours. That divides out to be 17.5 packages. So we could say like PKS per hour. Now, we're not actually going to sell half of a package, but this is an average amount. 1 hour we probably sold more, where the other hour we probably sold less. Same deal for the erasers. We look at how many hours, how many packages. So we get 15 packages over 3 hours. That gives me 5 packages per hour. So the difference between them is about 12.5, and you can see that pencil packages is going up a lot steeper than your eraser packages was. 21. A situation involving x and y where we have an equation y equals mx. What's the real name for this m value? If you went back to the front of your test and you looked at what that question was looking for, that m value that we talked about at the beginning of the video is our constant of proportionality. So make sure that you know how to spell that. You can abbreviate CP if you'd like, but make sure that you do know how to spell that. Sorry, I lied. This is not our last page. second to last page. I need to hurry up. So, if we have the number of eggs, a dozen, and the number of people, 4, and we want to figure out the constant of proportionality, well, that's either going to be people per egg, which to me doesn't really make much sense to split an egg among multiple people, or it's going to be eggs per person. So if it's eggs per person, I know that I want to put 12 eggs over my number of people, and that gives me 3 for my eggs per person, and that is my constant of proportionality, because every single person is going to get 3 eggs. So when we go to write this out as an equation, that would become y, the amount of eggs that we need, will be 3 times x, the amount of people that are eating omelets. Moving on to the final part of this problem, how many eggs will be needed if there's 20 people? We can then use that formula, y equals 3 times my number of people is now 20, which comes out to be 60 eggs will make 20 omelets, and I make some darn good omelets. At Manhattan High School, we are collecting soup and sandwiches for the homeless. 4 classes brought in these following amounts. Which 2 classes brought in the same ratio, not the same amounts, but the same ratio of cans to soup? So we want to compare cans over soup. So for Miss Smith, we have 12 over 18. We'll come back and simplify all these. For Mr. Frank, we have 15 over 10. For Miss Lee, we have 6 over 9. And for Miss Jones, we have 12 over 15. So when we go through and we simplify, we want to use the greatest factor we can to divide by. So 12 and 18 can both divide by 6, and that gives me 2/3. 15 and 10 can both divide by 5, and that gives me 3 over 2. So that is the reciprocal of Miss Smith. 6 over 9, both of those can reduce by 3, and that gives me 2/3. Well, I think I have found my answer there. But let's check. 12 and 15, what could they both reduce by? They could actually both reduce by 3, and this would become 4 over 5. But either way, we see that Miss Smith and Mr. Lee have that same ratio. So when we come down here and we look, Miss Smith and Mr. Lee, your answer B would be your correct value there. The final page, we're looking at another table. The table shows the cost of 4 magazines. We want to figure out which magazine has the lowest cost per issue. Again, cost divided by numbers of issues. So we work through this. 18 divided by 6, I already know is going to be $3. 32 divided by 8, that's what I thought, it's 4. 25 divided by 10 is $2.50, and 36 divided by 12 is $3. If we're looking for lowest, this $2.50 for telling now would be the cheapest price. So answer H would be your correct answer there. For this graph, we see Delaney carried a balloon, her brother tickled, and she let it go. Look at the axis values. We have the height of the balloon compared to how long it's been traveling. So we're asked for what is the constant of proportionality, and we talked about the constant of proportionality is also your unit rate. Your unit rate is always when the x value equals 1. So let's find out what is this y value. Well, it's not quite to 2, but if I come out here to another point, I can actually do a division to make my life real easy if I find a good intersection. Otherwise, I can just approximate. It's almost 2. Which of these options would make sense? B, 1.8 meters per second. That would make the most sense there. And our last 2 problems. A taco recipe serves 8. 8 what? Well, that would be people, and it uses 2 pounds of ground beef. So if I set up 2 pounds for 8 people, and then I say that Ted is making tacos for 12 people, well, that 12 would have to go on denominator because it's also people. I could actually relate this to a reduced ratio. I could say that 2 pounds for 8 people really means 1 pound for 4 people. Now I know that I can serve 4 people on 1 pound, How many pounds is it going to take to serve 12? Well, that triples. So that's going to also triple here. And we get 3 pounds of beef. Or you can use turkey. Turkey is really good to make tacos with. And finally, Miss Waters is building a table, and she drew a graph for table assembly. We are asked, what does the point 125 represent? Hopefully you can see this even though my little screen is in the way. So this point right here, 125, we'll analyze what is the 25. That's bolts. What is the 1? That's tables. So 25 bolts, 1 table. Either 1 table needs 25 bolts or 25 bolts are needed for 1 table. Either way, that statement says the same thing. No, we don't have any price involved on the graph at all. So get rid of option A. The origin is our 0, 0 point. Get rid of option B. 25 bolts are needed for 1 table, so the unit rate is 25. That sure seems to make sense because this went over to bolts and this went down to tables. Check D just to make sure we didn't answer too quickly. 1 bolt is needed for 25 tables. 1 bolt needed for 25 tables would make for some very dangerous tables. So option C is our correct choice there. It would be 25 bolts for 1 table, and that gives us what is also our unit rate. So if you guys have any other questions or concerns on why you missed what you missed on Chapter 2, please come see me. Otherwise, once you complete those corrections, go ahead and do the Progressing to Mastery, and then turn that in as soon as you get it done so that we can get it graded and updated in math. Thank you very much for your hard work. We'll see you guys later.